In the context of Azure Resource Monitoring and Maintenance, a Recovery Services Vault provides a specialized storage entity for backup data and site recovery processes. This vault can host backups for on-premises workloads, Azure virtual machines, and other Azure resources, ensuring long-term retention and streamlined restoration. While earlier topics focused on Azure Monitor, covering the interpretation of metrics, configuration of log settings, and query-based analysis of resource data, these insights now converge with recovery strategies to provide an end-to-end operational viewpoint. The Vault bridges data protection with alerting mechanisms, letting administrators quickly detect abnormalities and perform corrective actions. By storing incremental backups and leveraging built-in encryption, organizations can preserve service continuity and regulatory compliance. This means that recovery services vaults play a pivotal role in business continuity planning, aligning with the broader scope of Azure Resource Management, where proactive decision-making relies on robust backup and restore capabilities. Recovery services vaults serve two primary functions: backup and site recovery. With Azure Backup, administrators define protection policies that regularly capture snapshots of data, applications, and workloads. These snapshots are stored in an encrypted format within the vault, utilizing Azure's storage redundancy models for resilience. Through site recovery, an organization can orchestrate replication processes and implement failover strategies, minimizing downtime during outages or disasters. Key features include automatic storage management. The Vault works with Microsoft Managed Storage, eliminating the need to provision individual storage accounts. Fine-grained retention. Configure daily, weekly, monthly, and yearly retention points. Cross-region redundancy. Store backup data in secondary Azure regions for additional data durability. Role-based access control. RBAC leverage Azure Active Directory roles to regulate Vault operations. Together, these capabilities help ensure business continuity, aligning with broader monitoring workflows introduced by Azure Monitor. The Recovery Services Vault architecture integrates data sources, the Azure Backup Service, and failover orchestration mechanisms. At the highest layer, administrators define backup policies or replication strategies that detail how frequently resources should be protected and how long each recovery point is retained. When a backup job runs, data is transferred from sources, such as Azure VMs or on-premises machines, through secure channels into the Vault, which resides in a selected Azure region. Within the Vault, metadata is managed to track restore points and dependencies, ensuring quick retrieval when needed. The architecture typically incorporates four major components: 1. Data source, VM, app, or workload code. 2. Backup extension or agent for data encryption and transfer. 3. The Vault storage layer for protected data. 4. Recovery orchestration engine, enabling comprehensive restore workflows. This layered structure supports the strategic positioning of backups and failover events, seamlessly integrating with Azure Monitor's logging and alerting functionalities. To create a Recovery Services Vault in the Azure portal, access the Backup and Recovery section, then choose Add to initiate the provisioning process. Specify the resource group and target Azure region where you want to store backups. Once created, the Vault's dashboard presents configuration tabs for backup and replication settings. Administrators can define policies tailored to their business requirements, including daily or weekly backup schedules, retention duration, and encryption preferences. This graphically guided process also integrates well with Azure Monitor, where users can set alerts for backup job success or failure. If you prefer automation, you can utilize Azure CLI. Bash AZ Backup Vault create / resource group, your resource group / name vault name / location region. The integration with existing metrics and logs ensures alignment with previously discussed monitoring strategies, guaranteeing that each backup or restore event is trackable and auditable. Once the Vault is created, an essential step is configuring backup policies. These policies dictate when backups occur, how often incremental snapshots are taken, and the duration of retention points. For instance, A policy might schedule daily backups at off-peak hours to minimize resource contention. Policy enforcement is seamlessly integrated with role-based access control, ensuring that only authorized personnel can make updates. Azure Backup uses these policies to automatically trigger snapshots and store them in the Recovery Services Vault. Administrators can also implement multiple policies to address different workload requirements, such as short-term retention for development environments and longer-term archival for critical data. When combined with Azure Monitor, administrators can define alerts that trigger whenever backup jobs fail or exceed specific time thresholds. This synergy helps maintain consistent coverage, aligning with the broader theme of proactive resource monitoring introduced in previous lessons. After configuring the vault and backup policies, continuous monitoring ensures data protection remains effective. Within the vault's dashboard, administrators can review job history, identify unsuccessful attempts, and assess storage usage. Possessing a clear view of key trends, like the frequency of backup failures over a given period, facilitates prompt remediation. Additionally, integration with Azure Monitor lets you unify backup alerts with other system-wide notifications, centralizing event management. Through action groups, administrators can set up email or SMS notifications, thereby aligning backup operations with the broader suite of alert rules covered earlier. To aid in diagnosing issues, logs from backup operations can be queried using Azure Log Analytics, correlating with metrics captured across virtual machines, storage accounts, and network interfaces. This real-time and historical visibility underlines the comprehensive approach to resource management that the AZ-104 curriculum emphasizes, ensuring continuity, compliance, and operational awareness. Recovery Services Vaults integrate closely with Azure Monitor. By doing so, administrators gain insights into backup health, operational status, and performance metrics directly alongside other resources. This synergy means that telemetry, logs, and alerts related to the vault can be uniformly analyzed, enabling correlation with data from virtual machines, virtual networks, and other Azure services. For instance, if a particular VM experiences connectivity issues, Azure Monitor's insights can reveal how that disruption affects scheduled backups. Similarly, by leveraging log queries, it is possible to confirm whether policy-based backups have successfully completed. The table below outlines common metric types and their relevance when combined with Azure Monitor. Metric type purpose. Backup job success rate tracks backup reliability data. Transfer volume monitors volume. Changes SR health status validates site recovery state. Centralizing these data points provides a holistic perspective on infrastructure health.